Let's get into coding the player movement. Create a new mono behavior script and name it player. Add it to the player game object, double click on it to open it. Make sure you have a couple of the header files in there as they can cause some trouble. The first being Unity Engine and the other being Unity Engine.input system. Just before we start coding, let's quickly head back to our scene to find the input action in our project. If you don't have one, you can right click and create one. Double click on it to open it up. It should already be set up with the player and UI action maps, along with the default actions. As you can see, they have already been set up with the default joystick and keyboard controls in mind. If you want to go and set up these in detail, let me know in the comments below and I will try to make another tutorial for a proper setup. As for now, here is a quick screen grab of what the movement action looks like. You can check if these match yours, but there is not much needed as the defaults will definitely match. Here, all you need to note is the player action map and the move and jump action. Going back to our script, we will first declare a public input action asset variable named input actions. Then, another public character controller variable named player character controller. This will allow us to access the input actions and the character controller respectively. Now, we want to use the input actions once enabled and disable them once their work is done. So, add the first function private void on enabled. Inside it, type input actions.find action map player.enable to get the player action map. Likewise, create another function, namely private void on disable, and do the same step, except in this one we disable it. After getting the input actions done, we will further need our movement and jump actions. So, in the variable declaration, create two new variables, namely player move action and player jump action. Both of these will be of type input action. Now, we will need these actions to be active immediately after we start playing the game. So, we will create an awake function. Within this function, we will find the respective actions using input systems that action, find action, move, and jump respectively. We can store both of these in their respective input action variables. Perfect. We will now be able to read input of the movement. In order to finally start moving, we will need to create a couple of variables for the movement and jump variables. The first is the player walk speed variable, which we will keep to 5.0. Then, the player rotate dampening variable to smooth the rotation. We will set it to 0.1f. And finally, we will add a float variable named turn smoothing velocity to store the reference value, which we will need later on. Next, in order to account for the jump, we will create a float vertical velocity and keep it as 0. Then, we will hardcode the gravity to be negative 9.8 and we will add a jump height variable to signify the jump height and set it to 5. Finally, it is time to code the movement and jump functions. Start by creating an update function and inside it, we will grab our current movement amount. Oh, almost forgot. Create a private vector2 player move amount as well. We will set it to player move action dot read value vector2. This will give us a vector2 value of the player's movements. Let's first deal with movement. So declare a new function, player move and rotate. As the name suggests, this will handle both movement as well as the rotation aspects. Create a vector3 variable named player direction and equal it to the new vector3 value. This will take the x value of player move amount x and the y value of 0 because we don't want it to move up, and the z value of player amount y. We will end up by normalizing this value by adding dot normalized at the end. Next, we'll create another vector3 variable and call it vertical move. We will equal it to a new vector3 value of 0 in the x value, vertical velocity in the y, and 0 in the z value. We will also multiply it with time.delta time. Next, create an if statement. If the player direction.magnitudes is greater than or equals to 0.1, which basically means if there is even the slightest of input, then we will do the following. First, create a float target angle variable and equal it to mathf.a tan2 player direction dot x, comma player direction dot z. We will multiply this by mathf.rad to dig to convert it to degrees and add the player camera Euler angles dot y to the equation. Seems like we forgot to bring in the camera, so let's create a serialized field player camera. We will just need its transform, so we will use transform player camera. Next, we will determine the smoothing by creating a fourth smooth target angle and equaling it to mathf.smoothTampAngle. In the brackets, keep transform.eulerangles.y, comma, target angle. We will need a reference here, so ref turn smoothing velocity, and finally the dampening value, hence player rotate dampening. We will use this to add to the rotation value, so transform dot rotation equals to quaternion dot Euler 0 in the x value, smooth target angles in the y, and once again the 0 in the z. Finally, in order to move where the player is looking, we will account for it by creating a vector 3 value of move direction and equaling it to quaternion dot Euler 0 target angle and 0 and multiplying it by the forward vector value with vector 3 dot forward. Now we can finally bring it all together to add to the movement. So let's add movement to the player character controller by adding dot move. And as its parameter, add move direction dot normalized multiplied by the player walk speed multiplied by time dot delta time to make it frame rate independent. And finally, add the vertical movement as well with vertical move. Lastly, if there is no movement, we will simply only check for the player jumping. So, in the else part, add player character controller dot move. In the brackets, we will keep vertical move to check for any movement. That's the movement all done. Now, we will go to jumping. In order to jump, first create a function, jump. Within it, create an if statement where if the player character controller is grounded, we will add a small downforce by making the vertical velocity to -1. Similarly, within it, let's add another if statement to check if the jump action was actually pressed. So, if player jump action dot was pressed this frame, the vertical velocity will equal to the jump height. If the player is not grounded, we will simply set the vertical velocity to gravity multiplied by time dot delta time. Let's call all of these functions in the update function as well. Go ahead and add your input actions, player character controller, and player camera to the respective places. And we are all done. If you move your character and look around, everything will work as expected. Move around and rotate, and it will move towards the direction you are looking at. Perfect. Let me know what you would like to see next, and I will try my best to work on it. Namaste and good day.